Hi everyone, welcome back. This is Raju from Smart AI Technologies. In this session, we will be showing you a demo of a IEEE based project called handwritten medical prescription detection with help of deep learning and also machine learning. So before moving further, I'll just show a sample of the working and then we'll discuss about the IEEE papers based on which we improved our proposed methodology and we built this application. And after that, I'll be showing you the in-depth details of this project, which includes this website and what we done for the backend and the front end as a complete demo. If you are new to our channel, we Smart AI Technologies provide so many projects, okay, and machine learning, deep learning, and artificial intelligence. You can go through our channel, and if you find any project that you need, you can just contact us. You can call us to the given number. We will be providing that number below. You can either WhatsApp us. So you can choose any prescriptions. We have built this data set of prescriptions where I can load this. Now, when I click on detect medicine names, in the backend there will be models running. Okay, once that models, whatever we already trained, the saved model we implemented in the backend, that model will take this as an input and it will process the image. It will extract the words on that, or it means the medicine names, and then it will read out what is there in that and it will print us. The application seems very simple because whatever the complex stuffs are there, we made it to the backend. So everything will happen in the backend. That's what you can see here on the CMD. So many things will run on the backend. So for the front end, you just need to upload that image. You don't need to do anything. You don't need to select where is the medicine name. You don't need to say something about that. Okay, so this this prescription about this disease are like that. You don't need to pay medicine. You just push that, upload it, and it will be detecting what it needs, and it will give you the details. So now here you see aspirin and paracetamol. So that only we uploaded aspirin and paracetamol. So our result is also aspirin and paracetamol. So this is the first part. Further moving further for this, we'll be detecting what is the cheapest medicine brand available for this particular chemical medicine. So that's our next idea. And also, if you already saw our old video on medical prescription detection where we done for what disease that will be being used and all those things, because that's using different technique or technology. That's what we are going to discuss now. And there we didn't apply a web application with the front end and back end. We built that with the help of tkinter, a Python based front end. We'll be discussing in depth how we coded this. Before that, we will be discussing about the IEEE papers based on which we made our improvement. The first paper is this, which says medical prescription recognition using machine learning. In this paper, what they are using, how much accuracy they are getting, so all those things we'll discuss. So in the abstract itself, they are mentioning 70% of accuracy they are getting. As a result, they are using CNN model. But on the title, they are giving machine learning. They are using actually deep learning in the process. So we need to check their methodology first. So when you come to their methodology, they will be giving us all the details. Okay. Now, what are the things they are using for pre-processing phase? First, they are setting all the image formats, whatever data set they are using. Actually, they are using a data set of a different doctor's prescription. In our case, we built our own data set of prescriptions. These prescriptions images we captured using mobile Android and we collected them. So we are trying to make something very realistic with Android camera. Now all the image formats are set to PNG. First they will do that and then they will do grayscale conversion. Okay, they will do grayscale conversion and after that they are going to remove the noise and resize the image. Finally they're gonna crop white spaces, some extra spaces over that thing will be cropped out. So four things they are doing initially as a pre-processing part. Now here they are telling us that they collected these prescriptions from so many hospitals. In their case, they collected few number of prescription images. And the thing comes is, whenever someone uploads any prescriptions, first task is to detect where is medicine name, where is the name of the patient, where is the date. All those things are there. But in this case, this paper is not speaking about detecting particularly where is medicine or where is patient name or date. They just using a edge detection technique called Otsu segmentation with Sobel filter. These are all filters. Now they are not detection methods or models. So using that, they are going to detect a edge. Okay, edge. Based on the edge, they're gonna take out the rectangular part of that word. It means indirectly they are just doing word detection. Each word will be having some edge, so based on that the words will be detected. So it can't differentiate itself which one is the medicine name, which one is the patient name, which one is the date, which one is the like how many times that tablet will be taken, 2 times, 3 times. So it can't differentiate, it will detect the words. So after that, this paper is speaking about CNN model. Using CNN model, they are going to train it and they are going to get the result of 70% accuracy. CNN model. Okay. And they are using custom CNN model, and you can see the results here. So there are so many things which are missing because of the thing is that they are not training any detection model. They are doing it only based on the edge detection technique, which is not that much accurate. So if you are getting confused with what is this edge detection technique, normally, for example, this word is written here on the screen, you can see. So only that one is covered with that rectangular. What happened to others? That also can be covered with red boxes. Why they are missing? Because the code they are doing can't detect it as a edge. Okay, it can't able to detect edge there, and they will be setting up threshold. They set high threshold as I can see from above. Then only it is missing so many boxes. If they set low threshold, everywhere boxes will be there, and max suppression they did. So these are all very manual like stuff. They are not particular. So in our case, we are training a model which can able to detect exactly where is medicine name. Even though there are so many things on the medical prescription, it will detect only medicine name. It won't detect number. It won't detect tablet number of tablet or doses of the tablet. Anything. It even don't detect patient name, date. If we train our model separately to detect them, it will detect. But for now, we are training only to detect the medicine names. So our model is almost nearly 90%. Nearly, it means it's more than 90%. It nearly 90% accurately it will detect where is the medicine names. This is the first part. Now, as the second part, once you get where is the medicine on the medical prescriptions, what should be done? That is not much clear here. This paper is saying we are using CNN for that, but it is not clear. Okay, maybe hyperparameters are like that. There are so many things which are not very clear. So they are providing us this one first, 50 epochs. Okay, 50 epochs, they are running uh, this CNN model what they built, and 73% testing accuracy, 50% is there. Okay, 73 training and 50% testing accuracy they are getting. No much details here. So this is about the first paper that we are referring. And when it comes to second paper, okay, this says detecting and extracting information of a medicine from a medical prescription using deep learning and computer vision. In this paper is speaking about IAM database. They use IAM and written database specially to train what is there in particular word like this. If this word is house, how it contains, okay, in the previous paper they just told CNN, but in this paper they are mentioning they are using RNN model, actually NN model, RNN model they are using to train this. They used IAM dataset. Actually, this paper is based on our one of video, which you can see if you go through previous videos, you will understand. So based on that, one of student made their own research. They didn't just copy paste. Even we helped them. We helped that team to do the research, and they made it to IEEE because you need to do differently. Then only paper will be accepted. Okay. So this paper is done by one of our student, and I can see here. Okay. So for them, whatever we did is we used IAM handwritten dataset and we trained using RNN model, and for detecting the words on the prescriptions, there we used, in this paper we used ROI, region of interest, and as well as the edge detection techniques as I mentioned in the previous paper. Just like that, here also the same edge detection techniques are used. Based on that, the words are cropped out of the prescriptions, and finally they are adding all the classification report. So these results you can see in a old medical prescription based video, because this paper is the improved version of that, and we helped them to make extra research, okay, over that, and they implemented it and they made it to IEEE. Okay, and this will not be given as it is to everyone. Okay, you will be having your own unique upgradation. That's what I wanted to show here, because this is already based on our old video, so we can't give that as it is. We always make some improvement over our projects, because already one made to IEEE, you can't make another IEEE paper on this. So now if you want to take that project, we will first give you the proposed system over this, better proposed system over this again. Okay, if someone again makes that to IEEE, again improved version of that will be coming up. Always there will be an improvement in our projects. So our projects will be helping you even to make it to IEEE very easily, and some other research thing. Okay, not only IEEE, so many people will be publishing in some other okay. Now we discussed paper 1 and paper 2. What will be the next upgradation over our project? What we are doing extra, so that the next coming team will be able to make it to IEEE, some other research paper. Thing is, first thing we are doing is, for detecting only medicine names, we are not using ROI, we are not using edge detection. Only for detecting the medicine name, where is that? Sorry, only to detect the medicine. Where is the medicine on the prescription? That word, where is that particular word? For that, we are going to train a particular detection model. For example, YOLO V7, YOLO V5, YOLO V3, or if needed MRCNN. It depends. So there are so many multiple ways. For the first time, okay, for the first case you can say, or the first research step, we are using YOLO V5, and using that we are training a model which can able to detect exactly where is the medicine on the prescription. So its job is very easy. When you upload a prescription, it first take the image, it will detect where is the medicine, it will crop out that medicines, and it will give to us. You can see here. So crops you can see here. So this was the image that you uploaded. Now you can see aspirin and paracetamol are cropped out. So those things will be cropped out first with the help of YOLO V5. So YOLO V5 model we are training specially to detect, so the accuracy will be very high compared to normal filter based detections. Now this one we can display there, but I'm just giving out the results directly. Okay, how much accurate the medicine names, medicine part is detected. You can see those are so many things on the screen. 2 3 Sanjay Bangalore, okay, 11 11 8 22 21. So sign is there, so much of things are there, but we are detecting only medicine because that's what our interested region is, but with help of detection model, not with help of edge detection techniques. Once we do this, now we will be getting the crops. Now what is our next step is, I need to read what is there in that cropped image. So how I will do it? For that, again, I am taking even the IAM handwritten data set, and few extra images are added to that. Okay, some medical type written words are added to it, but it's mainly IAM handwritten data set of words. So we are taking it, and then we are going to add a few extra things here. The first one is image augmentation. In this paper also we are talking about image augmentation, but in the present task as an extended version, we will be adding data augmentation with some extra intensity changes, and also we will be applying some what is rotations. So rotation plus intensity changes. Intensity, the reason is very simple. Why we are experimenting with intensities? If I capture some medical prescription now with some light intensity, maybe daylight, okay, tomorrow that prescription will be captured with the mobile in some lighter, so that intensity change should not confuse my model. For that purpose, we are ourselves augmenting with intensity change. What is this augmentation and why we do it? All those things we can discuss in depth while you will be taking this project. You can buy the entire project, and will be supporting with the mentorship, and it will be implemented in your system, and also raw documentation will be given to you, where you can use that documentation to write reports and PPTs very easily. And in our proposed system, we will be adding front end and back end. Whatever the paper we suggest now, it is to the research stuff only. So whether we are making anything as an application where you can deploy into Google Cloud or AWS, and it will be useful for everyone. For that purpose, we are building this web application, which you can see. So it is built with HTML and CSS in the front end, and whereas Flask in the back end. Okay, so that Flask will be handling all this transaction, whatever is happening here. As a demo, you can see here, this is a home page. So I pasted a link which is generated here when I executed that python app.py a Flask application. So this is a home page, and here I have given two options. Either you can click on medical prescription detection using deep learning part, or either you can click on here as a verification. So when I click on verification here, it will take us to this page which we saw initially. So you can upload any image here. For example, I'll go with this ibuprofen and pseudoephedrine. I'll be uploading this medicine. Now in the back end, all these things should happen sequentially. First, it should be, this image should be go to that pre-trained YOLO v5 model which we trained somewhere in the Jupyter notebook, and we saved the model there. Okay, and we bought it here. So you can see pseudoephedrine and ibuprofen. So these are the two medicine names. The next part is, actually we are going to use this and make so many extra feature things. One of them is actually giving the low price or low cost medicines. Okay, which brand is providing the same content, ibuprofen itself, the low cost. It is our next idea. And next you can see we will be uploading few more images and we will be testing it randomly. Okay. And you can see the difference. This image is very clear with intensity. The previous was not that much. Like even the intensity changes are being included, because if someone captures some image now in the lighter darker region or area, or someone captures in very lighter area, the prescriptions intensity and the prescription will be changing. So our model should not get confused in that case. So the model should be very sensitive to light intensity. You can see here even RNN model is running. Now it detected codeine and anaglyph 6. Now you can upload few more images, and there will always be a little bit loss. So everything is not 100% accurate. There will always be a little bit loss here. Even you should include that. Okay, no model is 100% accurate because of so many things. Okay, we can do so many combination, and we can build a models, train the models, and we will be getting around 95-98% accuracy. There will be 2% remaining also. Okay, there will always be a loss, what we call is the loss. So now I am sending antihistamine and ibuprofen, so it is detecting 100% properly, and I'll be uploading few more images randomly here. So this contains 3, and we will see whether it can able to detect it or not. Cephalexin, Anadol, and ibuprofen. And even in future we can add it as an extra feature, that is how many doses can be taken is also there, but for now I am not including. If you come up with an idea like, okay, when someone scans any medical prescription, it should automatically tell you when to take the medicine, how many times it should be taken. Okay, the entire thing can be given as the next feature. So Panadol, Cephalexin, and ibuprofen. So those things you can see here, and I will be uploading few more complex words. Benadryl. So let us upload this. So here there is more light intensity in one side, so it is not bit clear in right side. Okay, we will be uploading this image, and as I'm mentioning you can approach us, you can directly call us, or you can just WhatsApp us. Okay, we will be helping you. Okay, we will be calling you and discussing you about this first, then we will be showing you a demo. Then when you see the demo, when you okay with everything, when you okay with this project, then only you can register it, and then you can buy this project. So this is also predicted almost 100% properly, and few more images I will upload, then we will conclude this video. So Excedrin, Panadol, and Afrin, you can see Excedrin, Panadol, and Afrin. We implemented so many medical prescriptions, and we are getting more than 98% of accurate results, that you can see here. And yeah, this was all about this project, and you can always call us about this project. And if you are new to our channel, please go and subscribe our channel. There are so many videos you can watch, and there are so many videos which are free for you. There are so many good videos like agriculture related videos, and also speaker identification, speech emotion identification, which are little bit free. We are giving even some course, part of course for free, Jupyter notebooks, where you can use that for your other projects. This was all about today. Thank you very much for watching this. We'll see in the next video.